Hello, everyone. Welcome to class. Today is our first homework review. We're going to go over all the homework problems from sections 1.1 and 1.2. Be sure that you've actually attempted all of the homework before watching this class. The purpose of homework is to learn and grow and practice. And it does you no good if you're just watching me do it for you. But this is a chance to go over all of the work, to review what you've done, and see how we arrive at the correct answer for every problem. Let's start by looking at number 1. Read the situation carefully, then answer the question posed. And I've highlighted some important words in each of these. Number 1, if I take 12 steps, then toss a baseball to you, how far did I walk? 12 steps. It's right there in the problem. Reading it carefully will answer the question. In number 2, Jimmy is the oldest of 4 boys. Steve is twice as old as Carl, and George was born the year before Carl. How many brothers does Jimmy have? Well, 3. Right there in the first sentence, it says Jimmy is the oldest of 4 boys. That means he has 3 boy brothers. In number 3, Allison has half a dozen oranges. She gives 3 to her mother and 3 to her sister. How many oranges does she have left? Well, she started with half a dozen. That's 6. She gave 3 away, leaving her with 3, and then gave 3 more away, leaving her with nothing. 0 oranges. Number 4. Shelly is sharing a dozen candy canes with her friends. She gives 4 to Sarah and 3 to Samantha. How many candy canes does Sarah have? Well, we're assuming that Sarah started with none until Shelly came onto the scene with her dozen candy canes. And then Sarah received 4. She gives 4 to Sarah. Sarah has 4 candy canes. Number 5. Again, we're reading the situation carefully, then answering the question posed. In 2014, John Baker purchased a new computer for $1,365. In 2015, he replaced the hard drive with a higher capacity drive that cost $79. In 2016, he upgraded the video card for $472. The new video card fried his power supply, which cost a total of $947 in replacement parts. What was the initial cost of the computer? See, all of these numbers here are here to confuse you. The very first sentence says that he purchased the new computer for $1,365. That is the answer. That is the initial cost of the computer. Okay, number 6, use an organized list to write every possible way that the event could occur. Flip 3 fair coins and record H or T for each in order. So this is a lot like the true-false question we did during lecture. At the end of that problem, I revealed that we can do outcomes raised to events. In this case, there are 2 outcomes, heads or tails. There are 3 events. We're flipping it 3 times. 2 to the 3rd equals 8 possibilities. And once you know there's 8, you can make 8 spaces. Start half with heads, half with tails. And then for the half with heads, do half of those heads, half of those tails. And then in the last column, we alternate head, tails, head, tails, head, tails, head, tails. Or you could just try to list out until you've exhausted your options and you can get 8 that way. But the organized list must have all 8 of these ways that the event could occur. heads, 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 tails, heads, tails, heads, heads, tails, 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 head, head, tail, head, tail, 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 head, and tails, tails, tails. Number 7, again, use an organized list to write every possible way that the event could occur. 3 teams in a recreational basketball league each play every other team. So a simpler case, 2 teams would be 1 game. We add the 3rd team in, which would have to play each of the other 2 teams. That adds 2 more games to the 1 initial game. And we would have a total of 3 games. What are the 3 games? Well, list them out. That simpler case of A, B, and then adding team C in, we would have to add AC and BC. So AB, AC, and BC would be our organized list, every possible way that this event could occur. Number 8. Use an organized list to write every possible way that the event could occur. Answer 3 questions on a multiple choice test with A, B, or C. So there's 3 possible outcomes, A, B, and C. There are 3 questions. That's 3 events. 3 to the 3rd would be 27 possibilities that we have to come up with. And we want to list out all 27. It's very similar to our pattern when we just had true, false, or heads, tails. It's just that instead of 2 things, we have 3 things. So 27 would be 3 sets of 9. Start 1/3 of it with A, another third of it with B, the third of it with C. 9, 9, and 9. Then alternate AAA, BBB, CCC. Finally, ABC, ABC, ABC. Do that for the A's, the B's, and the C's. And you'll end up with your list of 27. I think that's about the simplest way to come up with this list. Otherwise, you're going to have to try and come up with every possibility until you come up with all 27 of them. So we'll try to follow that pattern. Number 9. We're going to use an organized list to write every possible way that we can answer 4 questions on a matching test using A, B, C, and D each once. So the way I did this was I started with A first and then each other second. So if A is first and then B is second, our possibilities are C, D, or DC. Then if A is first and C is second, our other possibilities are B, D, and DB. If A is first and D is second, our other possibilities are B, C, and CB. Then I do it again for the B's. B first, A second, leaves C and D, D and C. B first, C second, leaves A and D, D and A. B first, D second, leaves A, C, and CA. Then I do it for the C's. C first, then each other one second. C first, A second would leave B and D, which could also be DB. C first, B second leaves AD or DA. C first, D second leaves AB or BA. Finally, I go through and do D first with each of them second. D first, A second leaves BC. which could also be CB. D first, B second leaves AC, which could also be CA. D first, C second leaves AB, which could also be BA. And that actually exhausts every possibility. We ended up with a list of 4, 8, 12, 16, 20, 24. But again, these questions weren't asking us to come up with how many there are. We actually want the entire list. So these questions should have taken you a while. Number 10, we want our list of every possible way we can roll a total of 5 on 3 6-sided dice. Assume that the 3 dice are different. That is 1 plus 1 plus 2 equals 4 is different from 1 plus 2 plus 1 equals 4. So maybe one's red, one's green, and one's blue. So we could actually tell, is that number on the first die, the second die, or the third die? So the way I approached this list, rolling a total of 5, the lowest possible would have to be a 1-1 combo because there's no 0 on dice. The lowest you can roll on any particular die is 1. So 1 plus 1 would have to leave 3 left over to reach 5. And then every possible way to have 1 plus 1 plus 3. There'd be 1 plus 3 plus 1 and 3 plus 1 plus 1. So I came up with 3 options there. Then the second lowest possible would be a 1-2 combo. We already covered our 1-1. How about a 1-2? Well, 1 plus 2 is 3, and that leaves 2 left over to get to 5. So now all the different ways to do 1 plus 2 plus 2. That would also include 2 plus 1 plus 2 and 2 plus 2 plus 1. And we can't go any higher. Why not? Well, there's the 1 plus 3 combo, but if we look, we already did a 1 plus 3 combo in our first round. And then if we went 1 plus 4, that's already 5. So the third dice is going to push us over 5. We can't roll a total of 5 with a 1-4. We raised up to 2. 2-1 is the same as 1-2. We've already done those. And the 2-1 combo also covers the 2-2 combo. 2-3 would be 5 already. Anything on the third dice would push us over 5. So there's no more than these 6 that'll give us a total sum of 5. 1 plus 1 plus 3, 1 plus 3 plus 1, 3 plus 1 plus 1, 1 plus 2 plus 2, 2 plus 1 plus 2, and 2 plus 2 plus 1. So you would have come up with those 6 answers. Okay, and the next set of problems, here we have 11 through 15. In each series, identify the pattern and use it to predict the next 2 numbers in the series. So in number 11, we have 1, 3, 5, 7, 9, and that one's not too bad. Those are consecutive odd numbers, or we're adding 2 each time. 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11, plus 2 is 13. So 11 and 13. And that pattern was consecutive odd numbers or adding 2. And number 12, we're given 1, 3, 9, 27, 81, and we want the next two. Well, 1 times 3 is 3, times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 729. The pattern we identified is multiplying by 3. The next two numbers in the sequence are 243 and 729. In number 13, we have 2, 3, 5, 7, 11, 13, 17, and you should recognize that from previous math or even from the lecture that we did. That's our list of consecutive prime numbers. Prime numbers, of course, are numbers that the only possible way to multiply to get to them is the number itself and 1. So for instance, 7 is prime because it's only 7 times 1. 17 is prime because it's only 17 times 1. 14 is not in this list because 14 can be 14 times 1, but it could also be 2 times 7. If there's anything besides the number in itself, it's not prime, it is composite. So the next two prime numbers are 19. We would skip 18. And then 20 is not prime, 21 is not prime, 22 is not prime, but 23 is prime. So 19 and 23 are the next two consecutive prime numbers to continue that series. And number 14, the pattern's a little bit more difficult to pick up. But if we examine what's happening each time, eventually it does get easier to spot. 1 plus 1 is 2, plus 2 is 4, plus 3 is 7. You can see we're adding one more each time. Plus 4 is 11, plus 5 is 16, plus 6 is 22, plus 7 is 29, plus 8 is 37. So 29 and 37 would be the next two numbers following the pattern. Plus 7 plus 8. In number 15, 2 times 2 is 4, minus 1 is 3. 3 times 2 is 6, minus 1 is 5. 5 times 2 is 10, minus 1 is 9. 9 times 2 is 18, minus 1 is 17. 17 times 2 is 34, minus 1 is 33. 33 times 2 is 66, minus 1 is 65. 65 times 2 is 130, minus 1 is 129. So let's just move on to number 16. In one particular video game, 3 gems appear on the screen, some red and some yellow. To win, you need to hit the yellow gems, but not the red ones. The gems appear 3 at a time and have started with the following pattern: red, red, yellow, yellow, red, 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 yellow, red, yellow, red, yellow, red, red, yellow, yellow, red, red. What would you expect the order for the next set of gems to be? Justify your reasoning. Well, it went through these 4, red, red, yellow, through yellow, red, yellow. And then red, red, yellow happened again. And then yellow, red, red happened again. So we would assume that next red, yellow, red would happen again. So the answer is red, yellow, red because the pattern seems to be repeating. Told us to justify our reasoning, and that's why. It seems to be repeating. Number 17. The most common tuning standard for musical instruments is called A440 because it defines the A above middle C as a 440 hertz sound wave. Under this standard, A tones in lower octaves sound at 220 hertz, 110 hertz, and 55 hertz. What would you expect the frequencies of A tones in higher octaves to be? Justify your reasoning. So below 440, we have 220, 110, and 55. Let's follow that in the other direction and see if we can find a pattern beyond 440 above it. So 55 to 110, that's a double. 110 to 220, that's a double. 220 to 440, that's a double. So we would assume that the next two would double to 880 and then double again to 1760. So 880 hertz and 1760 hertz because it is doubling at each step. Let's take a look at the next two. 18 and 19. These are more of those be careful what you're reading, don't think too hard about it questions. In number 18, if you take 37 pennies from a pile of 52 pennies, how many pennies do you have? You took 37, so you have 37. You might be tempted to do subtraction, but read the question. You take 37, how many do you have? You have what you took. You're not the pile. The pile is over there. Number 19. The display case in the front of the geology classroom is set up showcasing 12 igneous rocks, 7 sedimentary rocks, 5 metamorphic rocks, and 18 crystalline minerals. For the next lab session, the instructor takes 10 igneous rocks and 10 crystalline minerals from the display case. How many sedimentary rocks are left in the display case? Again, it's trying to trick you into doing some sort of subtraction. But the instructor took igneous rocks and crystalline metals from the case. The instructor did not remove any sedimentary rocks. So there are still 7. We started with 7. The instructor didn't take any away. There's still 7. Let's take a look at number 20. A frog has fallen into a well 9 feet deep, and it is trying to leap out. Each leap takes the frog 3 feet up, but it slides back down 1 foot before it can leap again. How many leaps must the frog make before it escapes the well? Okay, so leap 1, the frog's fallen into the well 9 feet deep, 9 feet deep. It makes a jump of 3 feet, and then we subtract 1. You'll see why it's important that we make the jump calculation before the slide 1 calculation before we're done with this problem. The jump takes us from -9 to -6, adding 3, and then sliding down 1, the frog's at -7 after leap 1. Leap 2, starting at -7, we're jumping up 3 before subtracting 1, so we're at -4 before falling. We end up at -5 at the end of leap 2. Leap 3, we're starting at -5. We are jumping up 3 feet. we're making it to -2 before we subtract the 1, and we make it back down to -3. Okay. Watch what happens on leap 4. On leap 4, we jump up 3, and we make it to 0 before we slide back down, and we get -1. But wait a minute. We're not at -1 because we, the frog, never slid down, because when we were at -3 and we jumped up 3, we got out. There is no slide at the end of leap 4. So we have to be careful to consider that fact. Otherwise, you might make a 5th leap that's not needed. So -7, -5, -3, you might have noticed a pattern of adding 2 and went, oh, well, leap 4 will be -1, leap 5 will be +1. So 5 leaps. But there's no 5th leap needed because of what's happening in the middle of each step. So that was the critical thinking for this problem. The leaps the frog must make before it escapes is 4, not 5. Number 21. In one recreational basketball league, each team will play each other team twice. If there are 10 teams in the league, how many total games are played? Well, the situation where each team plays every other one time is the same as the handshake problem that we did during lecture. And how did we deal with the handshake problem? We started with a simpler case, such as when there's only 2 people shaking hands. So when there's 2 teams, there will be 1 game. When we add a 3rd team, there will be 2 more games. When we add a 4th team, there'll be 3 more games. And we keep adding on, +2, +3, +4, +5. We have to keep track because there's no formula here. But we keep our list all the way up to 10 teams in the league. When we add the 10th team, there'll be 9 more games. So we got to go all the way up to the +9 number. That gives us 45. But 45 isn't the answer because each team plays each other team twice. The handshake problem models once. So we just double 45 to get 90 games played. Let's take a look at number 22. We have our alphabet names again. Different ones from last time, maybe. Alice's team in the recreational basketball league has 7 players. Alice, Bob, Carl, Diane, Elaine, Frank, and Gerald. Since only 5 players can be on the court at once, 2 members of the team will be on the bench. How many different lineups could this team possibly use? And the author leaves us a bit of a joke here. Ignore positional differences for players. Most of the team is not skilled enough to understand if they are playing as a center or a guard. So it would be pretty complicated if we were going to come up with lists of 5 people. So instead of focusing on the 5, let's just focus on the simpler version of the problem, which would be the combinations of people on the bench. Because if there's 5 people on the court, there's 2 people on the bench because there's 7 people on the team. It's easier to look at the people on the bench and make these 1-2 combinations. So looking at all of the combinations with Alice on the bench, could be AB, AC, AD, AE, AF, or AG. 6 possibilities. Moving on to the possibilities with B on the bench, we would ignore BA because we already accounted for that in the A's. So the B combinations that are left over are BC, BD, BE, BF, and BG. We're adding 5. Looking at the combinations with C on the bench, we've already covered A, C, and BC. The C combinations that are left would be CD, CE, CF, and CG. So we're adding 4 more. You can see where this is going. 6, 5, 4. Looking at the D combinations, we've already covered A, D, B, D, and CD. That leaves DE, DF, and DG. Notice we're also ignoring AA, BB, CC, DD because this isn't cloning. There's not 2 of the same person on the bench at any time. So AA, BB, CC, those aren't combinations that can happen. The E's that are left are EF and EG, which leaves 1 F combination left, FG. And that's it. 6 plus 5 plus 4 plus 3 plus 2 plus 1 gives us 21 different lineups. And we got that by focusing on the people on the bench instead of the people on the court. In each of these, the people on the court would be the rest of the letters. Okay, that's it for the homework questions from 1-1. Let's move into the questions from 1-2. In 1 through 5, we want the negation of the given statement. 1, the pen is red. The negation would be the pen is not red. Remember, to find negation, we introduce the word not into the statement. George does not like pancakes. This already has a not, so we would not. Double negative. Take the not away. George does like pancakes, or George likes pancakes would be the negation. 3, this coffee is cold. The negation would be this coffee is not cold. Not this coffee is hot. Yes, that's the opposite. Yes, they're mutually exclusive, meaning you can't be both cold and hot at the same time. But what about lukewarm coffee? You wouldn't call it cold, you wouldn't call it hot. There's a lot of different temperatures in between cold and hot. And the negation has to be true if the statement is false. The negation has to be false if the statement is true. There's no middle ground. So the negation of this coffee is cold would be this coffee is not cold. Number 4, the oak is a tall tree. For the same reason the coffee wasn't hot, the tree is not short. The oak is not a tall tree would be the negation of the oak is a tall tree. We're just introducing not. Number 5, Susie's artwork is very expensive. Susie's artwork is not very expensive. Just introduce not. In 6 through 10, we're still going to do negations, but they're not as straightforward. Little joke, they're not as straightforward. But they're not as straightforward as the other ones because these are negations of and or statements. Remember from lecture, the negation of an and statement would be not or not. The negation of an or statement would be not and not. So in number 6, we have Sam is happy and healthy. The negation would be Sam is not happy or not healthy. So we not both of those and change and to or. Number 7, the device is either a square or a rectangle. That's an or statement. So we would go, the device is not a square and not a rectangle. Not both of them, and change or to and. You need to wash and wax your car. That's an and, so we'll change it to an or. You do not need to wash or wax your car. Or if you want to be really wordy about it, you do not need to wash or do not need to wax your car. But the way English works, if we say you do not need to wash or wax your car, we get that we're not needing to wash or we're not needing to wax. Number 9, Donnie is not fast enough, or he did not try his best. So this is already a not or not. The negation of not or not would be an and statement, because the negation of and is not or not. Donnie is fast enough and he tried his best. Got rid of both nots, changed or to and. Ten is an and in disguise. Rob wants pasta but no meatballs for dinner. But is like and. Because Rob wants pasta and no meatballs is what Rob wants pasta but no meatballs means. So we're negating and, that changes it to not or not. But he wanted pasta and he did not want meatballs. So the negation of wanting pasta would be not wanting pasta. The negation of wanting no meatballs would be wanting meatballs. And we're changing but/and to or. So Rob does not want pasta or does want meatballs for dinner. Okay, let's move on to some problem solving. Look at 11 through 14. In 11, we want to find a counterexample to disprove the statement, if A times B equals C, then C divided by B equals A. And if, as you're going through numbers, this might seem like something that there wouldn't be a counterexample to, because this is kind of the definition of division, but there's an important piece missing from the second part. And that's that we can't divide by 0 ever. So if B is 0, then the division won't give us A back. It'll be undefined. So any example where B equals 0 would be a counterexample to disprove that statement. Number 12. Find a counterexample to disprove the statement, if the product of two natural numbers is even, then both of the numbers are even. So we just need to find an example where the product of two natural numbers is even, but one of the numbers is odd, because that would disprove this statement. And something like 2 times 3. Number 13. Find a counterexample to disprove the statement, if a polygon has 4 sides, then it is a rectangle. Draw any 4-sided thing that isn't a rectangle, and you've got a counterexample. For example, a trapezoid. Be careful that you don't draw a square and say that's not a rectangle, because by definition, a square is a rectangle. but a rectangle is not a square. Okay. Number 14, find a counterexample to disprove the statement. If P is an odd prime number, then P plus 2 is also an odd prime number. Something that would make that statement hold, for example, would be P equals 3 because 3 plus 2 is 5, and P equals 5 because 5 plus 2 is 7, and both 5 and 7 are prime numbers. But if we used 7 as P, 7 plus 2 would be 9. 9 is odd, but it is not prime. We can get 9 with 3 times 3. So P equals 7 is a counterexample. P equals 13 would also be a counterexample. And there's others as well that you might have come up with. Okay, let's have some fun. Moving on to number 15, my favorite part of that second lecture, the logic grid puzzles. In number 15, we have the situation that 5 friends were discussing ice cream and realized that everyone's favorite flavor is different. How convenient. Bonnie, Craig, and Tommy agree that vanilla ice cream is too boring. Given a carton of Neapolitan ice cream, Sarah, Tommy, and Bonnie would be very happy if one took the vanilla, one took the strawberry, and one took the chocolate. Between Amanda and Tommy, one likes strawberry and the other prefers pistachio. And final clue, Bonnie does not like orange sherbet. Our question asks, what is Craig's ice cream of choice? So let's work through our clues. So the first clue, Bonnie, Craig, and Tommy agree that vanilla ice cream is too boring. That's going to rule out Bonnie, Craig, and Tommy from vanilla. So we mark out Bonnie, Craig, and Tommy in the vanilla column. The second clue, given a carton of Neapolitan ice cream, Sarah, Tommy, and Bonnie would be very happy if one took the vanilla, one took the strawberry, and one took the chocolate. This rules out Sarah, Tommy, and Bonnie from pistachio, and it rules out Sarah, Tommy, and Bonnie from orange sherbet. So we mark out those. It also rules out Amanda and Craig from chocolate, strawberry, and vanilla. If Sarah, Tommy, and Bonnie each take vanilla, strawberry, and chocolate, that means that there's no vanilla, strawberry, or chocolate for Amanda or Craig. Now we see we have this space here with Sarah and vanilla by process of elimination. Sarah and vanilla is a star. And if Sarah likes vanilla, she does not like any of the other ones. Clue 3. Between Amanda and Tommy, one likes strawberry and the other prefers pistachio. That means that Amanda and Tommy are both ruled out of chocolate, vanilla, and orange sherbet. We don't need the fourth clue. Bonnie does not like orange sherbet. We already knew that from a previous clue, but we have what we need. So here's what we have right now. The question was, what is Craig's ice cream of choice? And by process of elimination in the orange sherbet column, Craig is the only one left. So Craig must like orange sherbet. We don't need to fill in the rest of the puzzle. We've answered our question. Number 16. Six friends had a friendly contest to see who was the best at getting a slinky to travel down a long flight of stairs at the park. Each tried twice and recorded their best result. Grace's slinky went half as far as Antone's. Don's slinky went twice as far as Kenji's. Zeke's best went 3/4 as far as Philia's. And Philia managed to get her slinky 50% further than Grace. How far did Antone manage to send his slinky? Let's work through our clues. Grace's slinky went half as far as Antone's. Now, this eliminates some options. Why does it eliminate options? Well, Grace is going to have a number that's half as far as something else. And 13 and 16 are half as far as 26 and 32. So Grace can only be 13 or 16, cross out the rest. Antone can only be 26 and 32, cross out the rest. Moving on. Don's slinky went twice as far as Kenji's. Again, that means Don can only have numbers that are double Kenji's. 26 and 32 are twice as far as 13 and 16, which means Don can only be 26 or 32. Kenji can only be 13 and 16. We're making progress, but we still don't have anything that can give us a deduction. Zeke's best went 3/4 as far as Philia's. Now we got to do a little bit of math. I mean, we had to do math with the doubling and the halving, but now we're 3/4ing. And 3/4ing is multiplying by 0.75. Zeke can only go numbers that are 3/4 as far as Philia's. 3/4 of 32 is 24. 3/4 of 24 is 18. So Zeke can only go 18 or 24. Philia can only go 32 or 24. And now looking at everything, we can make some conclusions. For instance, we have this process of elimination. Zeke is 18 steps. Which means that Zeke isn't 24, and that process of elimination means that Philia is 24, which means she's not 32. So she can get ruled out there. "24 is 50% further than 16. And the clue says that Philia managed to get her slinky 50% further than Grace. Philia was 24 steps. Grace is locked in at 16 steps. We revisit the first problem. Grace's slinky went half as far as Antone's. We just figured out that Grace was 16 steps. That's half as far as 32, so Antone must have gone 32 steps, which answers the problem. Yes, we can work it further and get everybody, but we only need to answer the question that was asked. which was how far did Antone go? Number 17. Ah, from the situation at number 16, whose Slinky made it 18 steps. We do need to go farther to answer number 17. Did we actually go farther, or did we have that already? We had that already. So we don't need to go farther. Earlier, we uncovered that Zeke was 18. Okay, let's complicate it up. Instead of looking at a square, let's look at one of those grid of 3 squares and number 18. In number 18, we have the information that 3 friends meet for dinner every month. From overhearing their conversation, why are you listening to their conversation? But you are, you're overhearing their conversation. You piece together the following information. Maybe they're being so loud you can't help it. Maybe it's not your fault that you're being rude. Okay. So, Rusty is not the doctor. Carly is the daughter of a doctor. Steve is either a doctor or a teacher. Tim is an engineer. Brian's father is either a doctor or an engineer. The question we want to ask is, who is Adam's father? Okay, let's go. Rusty is not the doctor. A very straightforward clue. We'll cross out where Rusty and doctor meet. That's a no. Carly is the daughter of a doctor. So Carly cannot be Rusty's daughter because Rusty's not a doctor. So that's a no for Carly and Rusty. That's a yes for Carly and doctor, which means nobody else has a doctor who's a dad. And Carly's dad has no other profession. So she can't be the daughter of the engineer or the teacher. Steve is either a doctor or a teacher. It means Steve can't be the engineer. That's a no-go for Steve and engineer. Tim is an engineer. Well, we already knew that Steve wasn't, but now Rusty isn't either. It's a no for Rusty and engineer. And that's a no for Tim being the doctor or the teacher. Process of elimination. Rusty's the teacher, which means no one else is the teacher. Process of elimination. Steve's the doctor. Brian's father is either a doctor or an engineer. That means Brian's father is not the teacher. It's a no for Brian and teacher. And since we know Rusty's the teacher, that's a no for Brian and Rusty. Process of elimination. Adam has the father that is Rusty, the teacher. So who is Adam's father? Rusty, the teacher. Number 19. This problem is difficult. If you're very good at these, maybe it wasn't so bad. I consider myself pretty good at these. And this one took me a while. But I got it. Martin is compiling a book of scientific essays. He has contracted 4 authors to each write 1 chapter on their topic of expertise. The piece in chapter 2 is either Dr. Melendez's essay or the piece about dinosaurs. Dr. Callahan's essay is about volcanoes. The chapter about earthquakes will appear 1 chapter before Dr. Ingram's essay. The essay about dinosaurs will appear 2 chapters before Dr. Melendez's article. What is the topic of chapter 4? Okay, let's start. Clue 1, the piece in chapter 2 is either Dr. Melendez's essay or the piece about dinosaurs. That means that Melendez's article is not about dinosaurs. So 1 no in this very big grid. 2, Dr. Callahan's essay is about volcanoes. That's very nice of them to give us this. Callahan is volcanoes, which means Callahan is nothing else. Volcanoes is no one else. The chapter about earthquakes will appear 1 chapter before Dr. Ingram's essay. So we know that the earthquake chapter is not Dr. Ingram's chapter. We know that the earthquake chapter cannot be the final chapter, since it's 1 chapter before something else. And we know that Dr. Ingram can't be the first chapter, because someone is 1 chapter before them. The essay about dinosaurs will appear 2 chapters before Dr. Melendez's article. That tells us that the dinosaur chapter cannot be the final 2 chapters. So it can't be chapter 3 or chapter 4. And it tells us that Dr. Melendez can't have the first 2 essays. So we've made our rounds, and except for the one that was explicitly given to us, so far we have nothing. Let's go back to. I should say, let's go back to an earlier clue. Let's go back through, I guess is what I meant to say there. The piece in chapter 2 is either Dr. Melendez's essay or the piece about dinosaurs. Well, we know that chapter 2 is not Melendez now. So chapter 2 must be dinosaurs, which means none of the other chapters are dinosaurs, and chapter 2 isn't any of the other topics. Going back to the 4th clue, the essay about dinosaurs will appear 2 chapters before Dr. Melendez's article. Since we now know that dinosaurs is chapter 2, It's 2 chapters before chapter 4. Dr. Melendez's article has to be chapter 4. So Melendez gets a star in chapter 4. Cross out the other chapters. Melendez isn't anything. I should say chapter 4 isn't anyone other than Melendez. Going back to clue 3, the chapter about earthquakes will appear 1 chapter before Dr. Ingram's essay. Melendez is chapter 4. Not Ingram. And since Melendez is chapter 4 and not Ingram, that means earthquakes can't be chapter 3. Because the earthquakes will appear 1 chapter before Ingram's essay, not 1 chapter before Melendez's essay. So now process of elimination. Earthquakes are chapter 1. Rule out the rest. Since earthquakes are chapter 1, and earthquakes appears 1 chapter before Dr. Ingram's essay, that means Dr. Ingram's essay is chapter 2. Rule out the rest. Ingram is also therefore dinosaurs. How do we get that? Remember, the piece in chapter 2 was either Melendez or dinosaurs. Now that we know Ingram is chapter 2, it must be the dinosaur piece as well. We also could have gotten that from the chapter about earthquakes being 1 chapter before Ingram's essay. We're almost there. I know this one's not fun. This is the most not fun I've had having fun ever. Dr. Callahan's essay is about volcanoes was clue 2. Earthquakes is chapter 1. Callahan is volcanoes, so Callahan can't be chapter 1. Process of elimination, chapter 1 is Sims, which means Sims can't be chapter 3. Callahan is chapter 3. We knew Callahan was volcanoes, so chapter 3 is volcanoes. What is the topic of chapter 4? Again, we got that from, let's go back down and focus on this corner here. Chapter 3 was volcanoes. And in the process of elimination, we have chapter 4 is oceanography. We have answered the question. We don't need to fill in these final 4 spaces. And then we read number 20, and it says, actually, you do need to fill in some of it at least. Now we're asked on which topic is Dr. Sims an expert. So this is where we left the table. We see Sims is chapter 1. Chapter 1 is about earthquakes, which must mean that Sims is earthquakes. Number 21. Yeah, one more of these. In 21, Adriel is researching the prices of personal submersibles, one-person submarines. Of the submarine built by Zephyr Waves and the one built by Deep Sea Incorporated, one costs $25,000 and the other is Marine 5. The submarine built by EcoMarine Limited costs $1,000 more than the Abbey EX4. The $28,000 submarine is sold by Zephyr Waves. The Abbey EX4 costs $1,000 less than the Cafater 6. Catheter 6? I'm going to go with catheter. I'm not a big submarine guy. Final clue, the $27,000 craft is sold by Marine Co. The question we want to answer is, how much does the Cafater 6 cost? Catheter 6. However I said I would pronounce it. We're almost done, everyone. Clue 1, of the submarine built by Zephyr Waves and the one built by Deep Sea Inc., one costs $25,000 and the other is the Marine 5. All we can take from that right now is that the $25,000 sub is not the Marine 5. So that's a no there. Clue 2, the submarine built by EcoMarine Limited costs $1,000 more than the Abbey EX4. That means that the EcoMarine is not the Abbey. And that means that the EcoMarine is not the least expensive. And the Abbey is not the most expensive. We have to allow for one being $1,000 more than the other. The $28,000 submarine is sold by Zephyr Waves. That one is a gimme. Zephyr is the 28,000. The Abbey EX4 costs $1,000 less than the Catheter 6. That means the Abbey is not the most expensive, but we already knew that. But now we know that the Catheter is not the least expensive. The $27,000 craft is sold by Marine Co. That's another gimme. A star for Marine Co. and $27,000. No's everywhere else. Process of elimination, the Ecomarine is the 26,000. And then by process of elimination, the deep sea is the 25,000. Let's go back through the clues with all the information that we've gathered since we've seen them last. Of the submarine built by Zephyr Waves and the one built by Deep Sea Inc., one costs 25,000 and the other is the Marine 5. The Deep Sea is the 25,000. Therefore, the other is the Marine 5. Zephyr Waves is the Marine 5. Put a star at Zephyr and Marine 5. Cross out everything else in the column in the row. Clue 3. The 28,000 submarine is sold by Zephyr Waves. We now know that the Zephyr Waves is the Marine 5. That means the Marine 5 is the $28,000 submarine. Clue 2. The submarine built by Ecomarine Limited costs $1,000 more than the Abbey EX4. Now that we know that the Ecomarine is the 26,000, that means the Abbey must be the 25,000. Cross out row and column. Answering the question given of how much does the Catheter 6 cost, the Abbey EX4 costs 1,000 less than it. Since we've found that the Abbey is the $25,000 sub, the Catheter must be 26,000. Finally, number 22, from the situation in 21, who makes the Steto G5? The Steto is 27,000. We got that by process of elimination. The 27,000 is Marine Co., which means Steto is Marine Co. And that's it for the homework for sections 1.1 and 1.2. Thank you for your attention today. I will see you next time.